Nuclear energy, what we do now for nuclear energy on this planet, and as you know, this encompasses, in the teens in terms of percentage of energy in the United States, but it's 70 or 80% of France's energy. It's a big deal in certain parts of the world. And of course, it's regarded rightfully as very dangerous. We wish we didn't have to do it, but we seem to be doing it anyway. So what is nuclear energy? It is essentially fission. It's the breaking apart of complicated atoms. So very shortly after the Big Bang, where there were very, very simple atoms, these began to coalesce in something called nucleosynthesis into bigger atoms, some of which, for instance, uranium, winds up on the planet Earth. We wind up with some uranium. We find it, and here we are 4 billion years later, breaking it apart and exacting enormous amounts of energy from the process that essentially Einstein discovered in the theory of special relativity, E equals mc squared. So a little bit of mass becomes an enormous amount of energy. So when you break that complicated atom apart, you wind up with slightly less mass than you started with, and you can, on a good day, you can harness that energy and do good things with it. There are operational issues that we've seen in, for instance, Chernobyl and Fukushima. There are the issues of disposal of nuclear waste, Yucca Mountain being the most controversial and kind of current issue. In other words, what are we going to do with this stuff whose half-life is 500,000 years? In other words, you make a decision to put up a nuclear reactor, you're making a decision whose impacts are going to last at least 500,000 years. That's a big decision.